All right, so then at the top here, what we have is sometimes you would like to be able to use L'Hopital's, but in order to use L'Hopital's, you must be taking the limit of a quotient. So right now, if I look at example A, it is not written as a quotient, but you can rewrite as a quotient. So, some of you on your quiz did not simplify negative exponents. I told you in here the expectation is that you rewrite as negative exponents. I was nice this time. Next time on a test, if you don't rewrite the negative exponents, you're going to lose points. Okay, because I was very specific. So here, if you are leaving a problem like this, you cannot use L'Hopital's because it's not a quotient. There's no top and bottom. So I need to rewrite. You have the limit as x is approaching positive infinity of x over e to the 2x. Does everyone see where that came from? Okay. So if I try direct substitution using infinity, we end up with infinity over infinity. Does everyone see? All right. So now we're going to use L'Hopital's. We've got the limit as x approaches infinity of 1 over what? What's the derivative of e to the 2x? We just did it, quote unquote, 50 times. Yes. 2e to the 2x. Okay. Now we're going to try direct substitution where x is equal to infinity, meaning a humongous number. What is 1 divided by 2e to the 2 times infinity? 1 divided by a humongous number, which is 0. That's what I heard. Okay, on the concept check, previous page. Okay? All right, now, this is another thing that you kind of need to think about. I need to rewrite this as a quotient. And also, too, you need to take a look at this unique way that they have written what x is approaching. Can someone tell me why they just didn't write as x approaches 0? It's 0 from the right. Look at what you're given and see if you can say again.
Take natural log.
That's right. So if you think about the graph of the natural log of x, the graph of the natural log of x actually looks like this. Okay? You cannot evaluate the natural log of 0. So you're approaching 0 from the right-hand side, okay? And it's very specific. So I need to rewrite b as a quotient. Not taking the derivative, but I need to rewrite it as a quotient. How could I rewrite it?
Take the derivative.
I just specifically said without taking the derivative. You have to rewrite it first before you can decide that you're using L'Hopital's. Okay, so if I write this, folks, the limit as x approaches 0 from the right of the sine of x over the cosine of x times the natural log of x. What's wrong with that? When I use, or if I try to use L'Hopital's rule, what do I have to do in the top? Oh, I have to use a product rule. We want to make this as easy as possible. Cotangent, yes. So it's okay to write it down and just think about what you have to do. So here we have the limit as x approaches 0 from the right of the natural log of x over the cotangent of x. Okay. If we're evaluating using direct substitution now written as a quotient before I even think about L'Hopital's, we're evaluating the limit using direct substitution, but we're approaching 0 from the right. So that means as I plug in values that approach 0 from the right, what's happening to my natural log graph? Where's it going? It's going to negative infinity. So using direct substitution, where x is approaching or equal to values from the right of 0, you get negative infinity. Now you have to think about your cotangent graph. So for those of us that have forgotten, here is, what's this value right here? Anyone remember when you're graphing a cotangent? It's 0, I heard it. What's this one? It is pi. Yes, it's all coming back. Very scary, right? Does it go, look here, does it go like this, or does it go like this? The first or the second?
First.
This one, like this? Cotangent goes like this. The other one that I did, which is like this, is tangent. Right? Remember, they're reciprocals of each other. Okay, so as we are approaching 0 from the right, where is my graph going? Positive infinity. So that means what I have is negative infinity over positive infinity, which we discussed in the beginning, still indeterminate, right? Okay, so now this is where we decide we're using L'Hopital's. Okay, so you've got the limit as x approaches 0 from the right of 1 over x over, what's the derivative of the cotangent? Negative cosecant squared of x. Okay? Okay, so now what this is, I'm just going to rewrite it. It's the limit as x approaches 0 from the right of 1 over x, or can I say negative x? Or just negative cosecant squared of x like this. I just rewrote it so it doesn't look like a complex fraction. What's the problem? Even if I plug in just for this, isn't it undefined? Okay, so can I rewrite this? How can I get this up here? Make it who? Yeah, make it sine squared, right? So this is the limit as x approaches 0 from the right of negative sine squared of x over x. So even if I still try to plug in 0 from the right, I have an issue. So what do? I tried direct substitution with 0 values from the right, getting close to 0. It doesn't. Yeah, I tried L'Hopital's again. Okay, but we tried direct substitution in between. It doesn't work. So now we have the limit as x approaches 0 from the right. The derivative of the bottom is easy. What is it? It is 1. Okay, what do I have to do here? What do I have to use? Yeah, so can I think of this, I'm going to write it right here in this little box, as negative sine of x squared. Does that help me a little bit?
Yes.
Okay, so I can see the layers to take the derivative. So what's the first part of the derivative? Yeah, can I write it as negative 2 sine of x like that? Okay, and then what's the derivative of the negative sine of x? Well, it's just, yeah, it's just positive. So then it's cosine of x? But does this now help? Can I use direct substitution now? Okay. What is the sine of 0?
0.
Okay, can I stop? With direct substitution, I mean, once you get a 0 and everything's being multiplied, what's your answer? 0. Okay, but do you see here, you could actually take the derivative twice. Maybe you had to do it 3 times. You just have to see. Okay, questions?